Hi everyone. This is a short video about solving systems of equations by using the substitution method. There will be two videos. One will be about solving by substitution. The second video will be about solving systems by using the elimination method. So let's just look at substitution here. Suppose we were given the equation 4x minus 3y is equal to 10. And I told you that, let's see, y is equal to 2. If I wanted to figure out what x was equal to, I would take that 2 and I would substitute it in for y, because that's what y is equal to. So I would simply do 4x minus 3 times 2 is equal to 10. And then I would get 4x minus 6 is equal to 10. And then I'd do 4x. Then I would solve. I would add 6 to both sides. I'd get 4x is equal to 16. I'd divide by 4, and I would get x is equal to 4, right? So I would just simply substitute that 2 in for y, and then I could solve my equation. So what if instead we're given this equation, 4x minus 3y is equal to 10. Instead, I'm given y is equal to this algebraic expression 4x minus 5. The way that we solve the problem doesn't change. I know what y is equal to. It's equal to this stuff. So I'm going to take this stuff, all of this, and I'm going to substitute it in for y, because that's what y is equal to. So this is what it would look like. 4x minus 3. And then in parentheses, here I'm going to substitute x minus 5 in for y. And then minus 10. Now I'm going to solve this equation. Now with this substitution, I'm going to do some distributive properties. So I need to clean this up a little bit. So negative 3 times x is negative 3x. Negative 3 times negative 5 is a positive 15. Notice now that instead of having an equation with an x variable and a y variable, I only have x's. And if I combine my like terms, I get x is equal, x, let me erase that. X plus 15 is equal to 10. And if I solve for x by subtracting 15 from both sides, we get x equals negative 5. So now I know what x is equal to. I need to figure out what y is equal to. So remember, in the original equation, in the original system, y equals x minus 5. Well, now I know what x is equal to. So I'm going to substitute negative 5 in for x. Negative 5 minus 5. So now I can figure out that y is equal to negative 10. And that's my solution. As an ordered pair, we would write negative 5, negative 10. Because remember, when we're talking about systems of equations, what we are talking about is a location on a graph, on a coordinate plane, where these two lines will intersect each other. So this line here and this line here will intersect at the point negative 5, negative 10. So when you're doing a system of equations, you do need to solve for both of the variables. Sometimes students will figure out that x equals negative 5 and they think that they're done, but you're not done, because you also need to know what y is so that we can represent the solution as a location on a graph. So let's take a look at another example. So suppose we're given the equation 2x plus 2y is equal to 8, and we're given another equation, x equals 2y minus 5. And we get the symbol here that tells us that this is a system. So I'm going to take 2y minus 5, and I'm going to put it wherever I see an x, because that's what x is equal to. So we write 2 times 2y minus 5 plus 2y is equal to 8. So I took 2y minus 5 and I put it where I saw the x. Now we're going to do the distributive property here. So we'll do distributive here. We'll get 4y minus 10 plus 2y is equal to 8. And now we can solve for y. I'm going to combine some like terms. 6y minus 10 is equal to 8. We can add 10 to both sides and get 6y is equal to 18. Divide both sides by 6, and we get y is equal to 3. So we're halfway done. We know what y is equal to. So then I can take either one of these top two equations here, and I'm going to choose the bottom one. The reason why is that it already says x equals. So I'm going to use x equals 2y minus 5. And in place of the y, I'm going to put that 3, because that's what we know that y is equal to. So x is equal to 2 times 3 minus 5. So we get x is equal to 6 minus 5, and that means that x is equal to 1. So now I know that my solution is the ordered pair 1, 3. So if you graphed these two lines, they would meet at the ordered pair at the location 1, 3 on an xy coordinate plane. Okay, so that's what substitution is. What you should notice, right, when we do a substitution problem is that we know something about one of the variables, that one variable is being described by the other variable. So suppose we are given this system of equations. 4x plus 2y is equal to 5, and then we're told that y is equal to negative 2x minus 4, and this is a system. So y is being described by this relationship with x, right? Negative 2x minus 4. So that tells me that wherever I see a y, I can take negative 2x minus 4 and I can substitute it in. So 4x plus 2 times negative 2x minus 4 is equal to 5. I took all of this stuff and I put it in for y in the top equation. Now I can simplify. 4x minus 4x minus 8 is equal to 5. Negative 8 is equal to 5, which is a kind of weird outcome. Since this isn't true, negative 8 doesn't equal 5, this should tell us something about this system. And it says, basically, that there are no solutions. Because we got something that isn't true. So that also tells us something about these two lines. And what we should know about these two lines, if we have no solutions, and we saw this when we did graphing, it means that these two lines are parallel. I think I spelled that wrong. I can't tell. So anyway, this is a short video about using substitution to solve.